Welcome everyone, Assam and Esikul. So this is the third video in the generative AI crash course, and today we will be covering prompt engineering, and we will talk about a very interesting aspect of large language model. It's called in-context learning. So I will start by a paper called Large Language Models Are Few-Shot Learners. So this is a paper introduced by OpenAI when they trained the GPT-3 model, and basically what they found out is that when they increased the number of parameters of GPT models to 170 billion parameters, they found out that a large language model can learn from a few examples that you provide in the prompt without doing any parameter update. So we will see this capability in action when we do a few shot prompts, but we will actually start with zero-shot prompt. So what does zero-shot prompting mean? So basically, it means that you take a large language model, and then you come up with a completely new task, and you give instructions to this task in your prompt, and then the language model can complete this task in a zero-shot way. So without seeing any previous examples in your prompt. So I will start by taking this. I'm actually using this website called Prompting Guide, or the Prompt Engineering Guide. It actually has many prompt engineering techniques like zero-shot, few-shot prompting, chain of thought. We also mentioned retrieval augmented generation. We will discuss it in the later video. So today, let's just start with zero-shot prompting. I will take this prompt. It says classify the text into neutral, negative, or positive, and you give a text, and then you expect the language model to give you the sentiment. So I will actually paste my the prompt into this code snippet. I'm basically using the OpenAI client, and I'm creating a chat completion, and I want to see what the large language model will generate for my prompt. So when I run this this code, I receive neutral. So the large language model can classify the text into neutral, and if I change the sentence to I think the vacation is bad, we can see that the large language model deems that this sentence is actually negative. So this was zero-shot prompting, pretty simple, I guess. But we can go to few-shot prompting. So in few-shot prompting, you are actually teaching the large language model new knowledge or new skills, and then you teach it through previous examples, and then you expect the large language model to learn from these examples, and then you give the last example without giving the result, and you want to see the actual response from the large language model. So here, for example, we give a few examples with their results. So this is awesome, and we give a separator, and then we say negative, this is bad, positive, wow, the movie is red, positive. So here, as you can see, we teach the large, we try to teach the large language model that we try to teach it that it should give an inverted sentiment analysis on the given text. So when the text is positive, it should output negative. So it's kind of inverted here. So I will take this prompt, and I will paste it into my code. So for the last example, this is actually where you want your language model to give an answer for. So yeah, I will run my code, and now for the last example, it was definitely a negative sentiment, but the language model gave positive. So the language model efficiently learned this new skill of giving an inverted sentiment. We've seen two techniques, zero shot and few shot prompting. I actually want you to see this in action in a very interesting library called LangChain, And LangChain supports using various language models from OpenAI and different language model providers. And it also supports few short prompt templates. So I will quickly start with the chat prompt template. And basically a chat template or a template concept in LangChain allows you to provide user parameters to your prompt, and then once you define a prompt template, you can complete it with the parameter values, and then you can send this to the language model, and then you can perform inference. So yeah, I guess I will just take this example here, and I will paste it right away. I'll just comment all of this. And so here we give the system prompt, and here also this is kind of in context learning for me, because you actually teach the AI bot to perform to behave as if the name is provided to it. So yeah, let's try this out. I actually need to install LangChain. So pip install LangChain, and so actually we need to import an LLM like this. Yeah, so I will also import this from OpenAI, and I think I will need this line here, and yeah, I think we can just put these messages like this, and I want to print the output. So here what we did is create a chat template. It has two parameters, name and user input, and we have injected two values of these parameters. So the name is Bob, and the user input is what is your name. And then we created an LLM, which is basically a client to OpenAI, and we generate the answer. So I will run my script, and the answer was, my name is Bob, how can I assist you today? So the language model actually learned that its name is Bob, right? And then it replied to my question, which was, yeah, what is your name? So this was this is how you actually use prompt templates and LLM clients in LangChain. We can also take a look at few shot prompting in LangChain. So if you check the documentation website, so in LangChain, you actually need to prepare a list of few shot examples, and then you need to prepare a template for each example, and then you create a template for the few shot prompt. So let's look into each step individually. So each example is actually a smaller part of your prompt, which contains some parameters. So there is this example where we want to teach a large language model to reply to questions by asking itself a few questions before replying with the final answer. So here in this example, we ask the large language model, who lived longer, Muhammad Ali or Alan Turing? And the large language model should learn to ask itself a few questions first. Are follow-up questions needed? Yes. Follow-up. What are the follow-up questions? How old was Muhammad Ali when he died? And the large language model will give an intermediate answer. It will say, yeah, Muhammad Ali was 74 years old when he died. And it will ask the same question about Alan Turing. It will give an intermediate answer for this follow-up question. And then from the previous thoughts, the large language model will give the final answer. It was Muhammad Ali because, yeah, simply Muhammad Ali was 74 years, which is more than 41 years when he died. So yeah, using the same methodology, the large language model should learn how to reply to the question based on a few short examples. So yeah, from this list of examples, we will teach the large language model how to reply. But we also need a prompt that describes how each of these examples will look like. And as you can see, each example needs two parameters: the question and the answer. And so yeah, we need to prepare a prompt template with two parameters called question and answer. And the template for the example is really simple. It's just you describe a question and you give the content of the question, and then you give the expected answer. Actually, you can have few short examples with much more complicated prompt template, but in this example the template is really simple. So here actually, when we format one example, this is how it would look like when you format your prompt with the very first example. The individual example will look like this. And the final step, when you do a few shot prompting in LangChain, you need to specify this few shot prompt template. You create it using the examples list and using the example prompt. And also you need like a suffix for your few shot prompt template. This is actually needed in LangChain, and you need to specify the input variables. And at the end, you can format your prompt. So let's quickly check this code and see how it looks like when we execute it. So I will also comment out all of this, and basically we import the needed classes from LangChain prompt template and the few shot prompt template, and we create a list of examples. And then we just create the prompt template like this, and we would like to format it. So I will run this script, and this is how it is formatted. So this is one example. It's basically specifying the question and separating the question and the answer with a new line. And then we need to create the few shot prompt template. I will actually remove this print. And we need to specify the examples, and we specify this example prompt. So example prompt is like it's just the prompt template. And we can format the prompt and see how it looks like after formatting. And as you can see, this is actually what the large language model will see as a whole. So it will see the question, answer, question, answer, question, answer, and question and another answer. And this at the end, it will see the final question. And we should expect the large language model to reply to this question. So we can perform inference using this prompt. So I will import the OpenAI client from LangChain. So from LangChain.llms.openai import OpenAI client, and I will instantiate this client instance. So here, as you can see, we are not using a chat model. We're using a simple completion LLM. And basically because the template is not really useful for chat, but you can actually find another prompt template for chat. I think you can find it here. So few short examples for chat models. So yeah, if you don't use a few shot prompt template for chat, you simply use this OpenAI client. So I will see the result of calling the LLM using the prompt. So I will do something like this. So prompt.format, and the input is we can actually just use this example. And let's call Python. Let's see the result. All right, so yeah, we provided some examples for the GPT model, and we asked a final question, and the language model learned from the previous examples that it needs to follow this methodology of thinking. Are follow-up questions needed here? Yes. And then it gives like the follow-up, an intermediate answer, and then after 2 follow-up questions, it will generate the final answer. So this is how you can teach language model new skills using few-shot prompting. And basically, few-shot prompting is one of the techniques to improve the reliability of a language model. You can actually find a very interesting cookbook about how to improve the reliability of large language models using various prompt engineering techniques. This cookbook is from OpenAI, quite popular in the industry. Of course, I will put links to all of these websites and documentation in the video description. So the last technique that I want to talk about is called chain of thought prompting. Actually, there's a lot of papers that describe this technique. Maybe one of them is called large language models are zero-shot reasoners. I think there's another paper that preceded it. It's called large language models are few-shot reasoners. And basically the idea is that large language models can exhibit reasoning capabilities to reply to your questions or to perform certain tasks. So you don't have to the idea is that you don't have to oblige the model to reply right away to your question. You can actually incite it to think step by step before providing the final answer. So here in the zero-shot chain of thought example provided by the paper, when you ask a kind of mathematical question, you ask the model to think step by step, and then the large language model will start to provide some thoughts before actually answering. And yeah, so in the prompt engineering guide, you can actually find another example of this chain of thought prompting. So usually you can teach a large language model to reason or provide a chain of thought either in a zero-shot way or a few-shot way. So what we've seen in this paper is the zero-shot way of exhibiting thoughts. You just add this prompt, let's think step by step. But if you want a more reliable way of exhibiting thoughts, you can also teach the large language model to do this using few-shot prompts. So here, in this example, you want to teach the large language model to say whether the statement is true or false in terms of odd numbers, right? So here the first example says the odd numbers in this group add up to an even number, and you give the numbers, and then in this prompt you give an example of thoughts that the large language model should think about before giving the answer. So here the thoughts is that adding all odd numbers actually gives 25, which is also odd, which means that adding the odd numbers is not an even number, which means that the answer is false. So instead of having the large language model say false right away, you actually teach it to do this intermediate thinking step. Yeah, so basically this is the third technique that I wanted to talk about. It is actually proven to increase the capability or the performance of large language models. So here the paper says, without any handcrafted few shot examples, zero-shot chain of thought technique increased the accuracy on this benchmark. It's called multi-arithmetic, from 17% to 78%, and on GSM 8K from 10% to 40%. And I think, yeah, this is also kind of proof that large language models can reason when you instruct them to do so. So I think this was it for today's video. I believe in the next video I will talk more about retrieval augmented generation, a very interesting technique that allows you to augment your large language model with your own data, and very crucial when you want to build AI application. So again, you'll find all the links in the video description. Make sure to follow me on LinkedIn and on Twitter, and feel free to reach out when you have questions. Thanks all.